Hey guys, what's up? I'm in the middle of editing this video right now and finishing this series. I'm actually in my college dorm now, believe it or not. I started this series in my house. It's crazy. It's been so long. But I just wanted to update you guys on something quick. So if we look at my code here, you'll notice that it's giving us these warnings. So I want you guys to go to your init audio function, and you'll notice that if you typed it out like this, these two things, it's giving us these warnings basically saying that these things were never used, these constants that we have. And that's actually because I just totally goofed up, and that's what happens when you're coding. So what you want to do is change these, actually delete what we just wrote there. And I'm pretty sure I said in a video that it was something else. These zeros in this function that says AU graph connect node input, just change those to the names. So this is actually our synth output element, and it's going to give me errors because I don't have everything set yet. And then this is going to be our IO input element, and then I'll show you guys what it looks like. And next, we'll move on to a variable called the program change command. Now, what exactly is this, and what are all those numbers like 0xC0? Let me explain this. In the glorious world of MIDI, we have something called a program change command. And this piano I have right here is, of course, running MIDI, so we can use this as an example. And what we're going to do right now, this is on the grand piano. Well, say I wanted to change the setting that I'm using. So instead of using piano, maybe I want to go to E piano. And right there, when I just did that, you notice it changed the sound. Well, what this keyboard did behind the scenes is over its MIDI channel, it sent a program change command, which allowed me to change it to a different program number, or patch number in this case. And you can see that all of the MIDI commands, such as the program change command, have different codes in hexadecimal. That's a certain numbering system that uses 0x. Whenever you see 0x, you know it's hexadecimal, and it also uses letters in the mix of numbers, which is kind of strange at times. But if you go to this website I will include in the description, it has all the MIDI codes for all the different MIDI commands, so you can just look up the code that corresponds to each command. So the program change command, we can see that it would be 0xC0, and that's why in the code you see that we have that hexadecimal code. So let's take a look back at the code. We create a constant, let program change command equal unsigned integer 32. And what we're going to do for this notation is we're going to do 0xC0. That's our MIDI command to change the program command. And then we're going to do that kind of line thingy, and then space and channel. Now that's the MIDI channel that we're working over. So that way it can look for that command, the program change command, over our MIDI channel. And after that, we can finally do our music device MIDI event function, of course, pass through our check error function. And inside this function, which is also part of the API, our first argument is the synth unit. And in this case, it's a good idea to use self.synthUnit because we can directly reference the object, and that way we don't get any mix-up of values. So it's good to do that once in a while, just to make sure you have the proper synth unit. And then our second argument is going to be our program change command. So if we take a look back, we remember we set the command number, C0, and then our channel. So that's going to look out for that command on our channel. And then finally, we need our program number, which is our patch, as the third argument. And then the last ones, the other 0, we don't use because in MIDI commands that part is not used, the in data 2. And then the other one is the offset sample frame, which we're just going to leave at 0 for now. So what's going to happen once this music device MIDI event is running and the computer detects that there was a program change command, it's going to run another function, which is audio unit set property. You guys know the arguments at this point. It's pretty much the same, except for the second to last argument, we use our and disabled, ampersand disabled, to disable that property. And that's exactly what Apple told us to do. They told us when we get that program change command, we actually want to disable the preload, because at this point, we've loaded our patch, we've received the command from the user to load a certain patch. And this is what we would do if we had the option to change that patch. But in this case, we're not going to change it. We're just going to leave it on the piano for this video. But let me know in the comments below if you want to see how we can change the different instruments in the future. And finally, the last function inside our load patch function is another music device MIDI event. We use our synth audio unit exclamation as the first argument, our program change command, our patch number or program number, and then the zeros again that we used at the end. And this is actually going to load our patch or trigger it to load a different instrument instead of just the preload. All right, guys, there's not much left to do and we're approaching the end here. So let's go back to our init audio function. And now what we're gonna do at the bottom of that, we're gonna call our load soundfont function and then our load patch function. And the patch number we're gonna start out with is 0 because we wanna load our piano. And that's it for this class, our speaker class. So now what we can go ahead and do is we're going to create a new file. In this file, we're gonna call synth. And we need to import the core audio and the AudioKit frameworks in order for this to work. Now what we do here is this is actually going to be a final class. And what a final class allows us to do, it allows us to add some additional functions to our other class and actually use that in another class. It's kind of confusing, but we'll show you how it works in a second. So with a final class, we're gonna call this one final class synth of type speaker, which is our class that we just created. And then after those brackets in the beginning, which you definitely need for each class, you're gonna need them. After those brackets, the first thing we're gonna do is override init with those parentheses, and you'll see it appears pink. This is because it's a default function that we can use. And we use brackets, again, you always need those with functions. And inside those brackets, we're gonna do super init, which is going to load everything from our previous class. And of course, now we're going to actually call those functions because they were never called in the first place. But now creating this final class, we can call them. And this is like the main function that we use in this override init. This is everything inside this function is going to be run as soon as our view controller loads or as soon as we create another instance of this class. So we do, after super init, we do init audio, remember that function? Then we do load soundfont and load patch with our patch number 0. Yo guys, what's up? I'm editing the video again and I just thought it'd be important to mention that this load soundfont function, it's the load patch function. Using that function, when we put in a 0, just like I said before, we're using the piano. So when we use a 0, that's gonna change it to the piano. Now we have no way to change the instrument to different numbers, so we just kind of type it in the code right now. So you could look up, there's actually all the patch numbers correspond to a different instrument. So you could look up on Google, Fluid R3 GM sound font, and just look that up and see what numbers correspond to which instrument. And then whatever instrument you want, you can change it to that number. So with this load patch function, you could just type in like 30 if it was gonna play the flute or something. I had someone reach out to me in the comments section below saying they wanted a steel pan sound. You can totally do that. In fact, I'm gonna make a separate video on this just because I think it's kind of cool. But for now, just realize that you can change the instrument. It doesn't have to be a piano, so just change that patch number to whatever instrument you want it to be. Then after those, we're going to set a couple properties. First property is going to be our octave. So there's going to be 4 octaves. And currently we won't be able to change the octave number, but let me know if that's something you want to do, and we can do that in the next video. And our MIDI channel, of course, is going to be 0, and the velocity of each note by default is going to be 127. So it's going to be at the maximum velocity. I don't know if there's a way that we can make it sensitive, but if you guys want me to do more research on that, I can do it as well. But for now, we're just going to leave the velocity constant, so we're just going to do it at 127. And finally, we're going to do a couple last functions. First one, play note on. This is what's going to happen when we hit a note on the screen, when we press one. In this function, couple of arguments, the channel number, the note number, and the MIDI velocity. All are integers, but for the note, we did unsigned integer 8-bit. So an 8-bit unsigned integer, uint8. And then inside the note on function, we're going to let our note command be the 0x90, which is the MIDI note command, just like the program change command, but it has a different code. So make sure to check out that website in the description. And then we're going to let the bass of our keyboard, equal note minus 48. This is because we have 48 notes, 12 notes for each octave, 4 octaves. So that's why if we do note minus 48, that can get us our bass note if we need. And then octave adjust, we're just going to make this a little kind of math function that will allow us to adjust the octaves. So we just do let octave adjust equal uint8 parentheses octave times 12 and then plus the bass. And then our pitch is actually going to be uint32 octave adjust. So that's going to let us actually use the sound and make it our piano sound. Kind of simulates the piano. And then finally, check error, music device, MIDI event, synth unit, note command, pitch. And then the other data we're going to use is our uint32 MIDI velocity, which if you remember, we set it to 127. And then the offset sample frame again, which is 0. And this again is going to look for our note command, and whenever we play that note, play note on, it's going to play that note with the given velocity. So that's what it's doing. And then finally, play note off, pretty much the same, except this is a different command, 0x80. So just the same, but instead of 0x90 for that note command, we do 0x80. And that right there is our final class of synth. Now we can go back to our view controller and set up all the necessary things that we need for our keyboard to actually play sound. But before we continue, I just wanted to give a quick shout out to AudioKit. For those of you who don't know what that is, you should know what it is. This is where we're using it in this video. It's a framework that allows us to do cool things such as these play note on and play note off functions. If we didn't have AudioKit, we wouldn't have those. And these functions are very important for allowing our keyboard to work on our iPhone. So shout out to them. It's an amazing framework that allows us to do so many things, and it's completely open source. And they have some amazing apps on the App Store also, so definitely check them out. Now back in our MIDI view controller class, we're going to, in the beginning of the class, we're going to create another instance of our synth class that we just created. And this is going to allow us to access all the instance members of that class. And then a couple new functions we're going to add is func set speakers as default audio output. And this one's kind of tricky. I'm not going to go into a lot of detail, but you can just copy it down how it is. It's going to use Apple's AV audio framework to allow us to enable the output to our speakers, which is something we definitely need. So if this function is giving you any errors or any trouble, make sure to leave it down in the comments below, or sometimes you can even click on that error and it will give you an option to fix it, which you should definitely do. But if it's still bothering you, just make sure to let me know or let somebody else know, and we'll try the best to help you. And then finally, we are going to do another function, which is going to be load voices. And this is going to set up a new background thread that's going to allow us to load our voices in the background. So as the app loads up, it's constantly going to be loading our patch when needed. And it's going to be using this by this dispatch queue.global QoS background. Basically, this is just the syntax to allow it to run in the background. So make sure you copy that down as well. And then finally, we're going to add a new extension. We already have our keyboard set up, but now we're going to add an extension at the end of our class. And this extension, you want to make sure that you actually add it outside of the class. And then what we do to create an extension is we use the word extension, MIDI instrument view controller, which is our view controller class, and then of type AK keyboard delegate. Now we're to the AudioKit part of this video. We're going to be using AudioKit's MIDI to help us connect our MIDI input to our keyboard. So whenever we play a note, it's going to use that nice keyboard created by AudioKit to help us use it as a piano. So inside this AK keyboard delegate, two functions, just like the previous class, note on and note off. And our note is going to be of type MIDI note number. And this is part of AudioKit. Again, it's all managed by AudioKit, so it's pretty nice. Don't have to write much here. And inside each of those functions, if it's the note on number, it's going to be synth.playNoteOn. Remember that function we created? And then in the note off, synth.playNoteOff. And then everything else for the other ones is pretty much the same. Channel is 0. And the note in the note on one is just note. And then the note off one is unsigned integer 32, note. And then MIDI velocity for both of them is going to be 127. And after we've done this, I can tell you guys, it's been a long video, but you should feel good because you just created your first piano app with AudioKit and Apple's Core Audio API. Let's go ahead and test it out. Hold up, I forgot a couple of lines of code that we're going to need, and my apologies about that. Sometimes when you're into it, you just forget about some stuff. So first of all, in our override func view did load, we need to run our set speakers as default audio output, and I think our setup piano keyboard function should already be in there. But we also need to run our load voices after that. So make sure you call those three functions in your view did load. And then finally, in our setup piano keyboard, we need to add two more lines of code. First being keyboard.delegate equals self. That's just going to use our delegate extension that we just created and connect it to the keyboard. So when we press a note, it's going to actually register it. And then finally, if you want to be able to play more than one note at the same time, allowing you to do chords, you want to do keyboard.polyphonic mode equals true. All right, guys, here is the moment of truth. We're about to run this application, and let's just pray that we don't get any errors or anything. So what you're going to do is press this play button right here, and I'm just going to build it on the iPhone XR. You can select what iPhone you want up here, and it will just open it up. So it should open up in a second here. It's just doing some stuff. We'll give it a little bit, give it a minute, let it do its thing. All right, we got no errors, at least syntax errors, that is. There are runtime errors which happen when your program is already running. I learned about that in CS 1301, which is a class I'm taking. Awesome. It's pretty fun right now because it's easy. If you're loading it for the first time, it's going to take some time to load. So just give it a little bit, be patient, do whatever you need to do, check your Instagram. By the way, if you're not following my Instagram, it's at evanmurray._. You should totally check it out. I post a lot of behind the scenes stuff and just general stuff that I'm doing in my life. So if you want to stay updated, make sure to follow. It's still loading. Jeez, okay. It's installing, and it will look kind of funky because we never gave it an icon. And white screen, but that's okay because I think it's loading the keyboard. This is taking a while. I'm kind of nervous. Oh, here we go. We got our piano. So here's a test we're gonna play. Ah, shoot, I can't play it very well because I'm using the mouse. Dang it. Okay. Yeah, as you guys can tell, it's working. I'm very happy. And I don't know how to do this on the mouse, but since we enabled this thing called, where was it? Polyphonic mode, I can't really do it very well on the mouse, so I can't show you guys, and I can't film my iPhone because I don't have my camera with me right now. But if you guys were using your fingers and you press 2 notes, like you press those at the same time, it will work since we have that polyphonic mode enabled. But yeah, there you guys go. We made our piano app, and I'm just gonna give you a little demo of what the next video is gonna be. So let's go ahead and go into our speaker class here. This is just a little demo. You can not care if you want, or care. I just want to show you guys one valuable thing. So what we're gonna do, we're gonna change the instrument instead of having a piano. And how I told you guys to do that, we're gonna change the patch. So I'm just gonna change this to 5. Wherever I see patch number, change it to 5. And I think that's it. There's no more other. Yep, that just does the patch. And then if we go into our synth, load patch 5. And I think that's all of them. So we're just gonna build this again, see what happens. Oh, and also another cool thing, you can plug in your iPhone to your Mac and run this app on your iPhone as long as you have a developer account, which is free if you're not submitting your app to the App Store. So everybody can run this on their iPhone for free, which is awesome. You can show your friends what you made and be proud of it. I like to do that sometimes. So yeah, this is gonna play a different instrument. Oh no, it didn't. It should play a different instrument, but it's not. Wonder why. Alright, let's try patch number 10. Someplace we forgot to put this. It's not doing it right now. Kind of disappointed. I thought that was gonna work. Ah, here it is. This thing right here. See this? Load voices in the view controller. Basically anywhere it says load patch, you have to change it, so make sure to do that if you want to change the instrument. Again, I'll release another video on how to do this more detailed, and we'll be creating a steel pan app, which is going to be pretty cool. So stay tuned for that. Alright, let's see if this works. Come on, please work. I'm about ready to be done with this video. It took a long time to make, so if you guys want to do me a favor, smash that like button if you appreciate it. Lets me know that I did a good job, and if there's any feedback you can give, that'd be very helpful as well to let me know what I can do better. But alright, let's test. Hey, that's kind of pretty. It's like some bell sound. I think it's like a vibraphone or something. But anyway, see, we changed all the patch numbers, and that gave us a new instrument. Sorry about that. Let's quit that for a second. Alright, so yeah, there you go. That's going to be in the next video. The basis for the next video is that we can actually change the instrument here. And in the next video, we're also not going to use this piano keyboard layout because I want to create a steel pan layout. So it's going to be like a drum, like a kind of like this graphic right here, but it's going to be like a flat, you know, just a circle basically simulating a drum, and then there's going to be like buttons like you would have on a steel pan, and we're going to be able to play that steel pan sound instead of this like bell sound. But anyway, stay tuned for the future videos. If you like this one, make sure to leave a like and subscribe if you want to see more, and I'll see you in the next one. Peace out.